Hi guys. So in the last video, I have explained about one important data structure in array that is sliding window. Okay. So in what type of problems we have to make use of sliding window that we have discussed. So we have discussed like while calculating maximum subarray sum, there we are making use of sliding window with a certain specified window size that has been provided to you. But today we will be discussing some other aspects of the array data structure, that is prefix sum or prefix product approach. Okay, so this is also a very important data structure of array. Okay, and it is being asked in the interviews as well. Okay, so in what type of scenario prefix product or prefix sum approach will be applied, that we'll be discussing in this video. Okay, so let's understand prefix product approach first. So what type of scenarios it can be applied to? So in I will send you some example. Okay, with that example I will be explaining you in what type of scenarios it can be applied. Okay, one problem statement, that is product of array except self. Okay, so product of each and every elements we have to calculate, and before that element, whatever elements are coming, we have to calculate a product of it. Okay, so product of array except self, that is the problem that I will be explaining it to you. So what's the meaning of this product of array except self? So let's suppose I am taking one example like 1 9 4 3 2. Let's suppose I'm taking one example. So I want that at each index, I want to calculate a product of all the elements of the array except the given index value. Okay, so what do I mean by this? I mean, like when I'm selecting the first index value, I want that it should have the product of all these elements, like 9 into 4 into 3 into 2. Okay, so whatever value will come, it will come at this particular index. Okay, that is the first index. Second index, that is at ninth, the value 9 is coming at that particular point, that is at second index. I want the multiplication of 1 4 3 2. Okay, that is 24. It should come as 24. So I hope you got the concept here. So at each and every index, I want the product of all the elements of the array except the element which is present at that particular index. So similarly here also. So here the product will be 1 multiplied by 9 multiplied by 3 multiplied by 2. It should not contain this particular element where we are having, okay, where we are going at the index position. That particular index value should not be multiplied. So that is the basic output that I want. Okay. So this will be as coming as 54. So like that, all the elements will be coming over here. So how will you approach this type of problems? How will you move ahead while solving this type of question? So try to pause here and try to think about it, like how to solve this type of problem statements. Okay. So a basic brute force approach will be what? The basic brute force approach will be, you will run a loop from first index till the last index. Okay. And then you will be checking like where is the current element, where is the current index value, and wherever the current index value will be there, you have to skip that. Okay, and then you have to multiply all the elements. You have to take one variable and you have to store one into it, and then we have to multiply each and every time to all the elements. We have to multiply with that particular index value. Okay, whatever you are setting there, and then we have to keep on multiplying. So let's suppose I'm going to this particular index. Okay, so it will multiply all the elements, so we have to run a loop again. Okay, like two for loops we have to apply. So again, whenever I is moving to second index, okay, like first 0 and 1, okay, this is I equal to 1 over here. At that point of time, we have to run a loop from the first index till last index again. And whenever we have to see like whether index is coming at that particular value where I, which is the first for loop, is there or not. So for I equal to 1, whenever I is as first index, at that point of time, we will be checking if j is equal to I. Okay, so we are running two for loops, right, for calculating product. So whenever j becomes equal to the ith index, so we have to skip that. We have to continue it. Okay, and then the rest part we have to keep on multiplying. So this concept you have to apply. But what's the time complexity for this? The time complexity will become O of n square. So can we optimize it to O of n? Will that be possible? So this is the question that I'm asking to you. So try to think it out loud in your mind, like how can you think of optimizing this approach from O of n square to O of n? So currently the time complexity will be O of n square. Okay, I need to optimize it from O of n square to O of n. How will you optimize it? That is the main problem over here. So to optimize this type of problems, how can you proceed ahead with it? So here we have to make use of prefix product approach. Okay, so this concept we have to make use of. So this is a kind of algorithm that comes in under array, where we are optimizing this type of problems from O of n square to O of n. So how we can apply that, that we will be understanding now. So in this, what we have to do, we have to maintain two arrays. One will be the left array. Okay, one we have to maintain is the left array. Okay, and another one which we have to maintain is the right array. We have to maintain two array basically. So in the left array, what will happen? In the left array, what data will come? So in the left array, data will come as, let's suppose I am at this particular position, first in zeroth index basically. So we nothing will come in the left side. Okay, so first index value will be considered as 1, because if we don't consider anything, then by default the value will become 0 and all the elements will be multiplied with 0 as the initial element. So we have to set the initial element as 1, the initial value as 1, the initial index value as 1, irrespective of whatever element over here is present. Okay, because the left of the first index is nothing. Okay, so we have to consider the 0th index as 1. That is the first concept that we have to apply when we are doing the product from left side of array elements. Okay, so now when we are moving towards the next index value, okay, so now we are moving towards the next index value, that is 9. So what will be the left product of this particular index? The left product of this index will be 1. Okay, so the left will be now 1 for 9. Okay, now when I'm moving to 5 or 4, let's suppose it's 4, then the left product for this 4 will be 1 into 9. Okay, that will be 9. Okay, and whenever the pointer is coming to 3, the left product for this will be 9 into 4, which is 36. Okay, and whenever it is moving to 2, the left product will be 9 into 4, 36 into 3, 108. Okay, so this will be the left product of any elements going forward in the array. So we are maintaining a specific array where we are traversing and storing the left product values as we are traversing. The same we have to maintain a right array for the same. Okay, so when we are moving from the right, we have to assume that a rightmost index is having value as 1. Similar to this, the leftmost index we have set it as 1. Similar to that, the total array dot length minus 1 index. So this index will be coming. So this index value will be considered as 1. So let me tell you, it is not the exact value of the array. It is the right product of each element that I am storing over here. Okay, this is a separate array which we are creating. So rightmost element value will be considered as 1 first, so that we can multiply and we can calculate the right product arrays. So now the pointer will go to the next index from the right. So whenever the pointer is at 3, that means length minus 2 at index whenever the position will occur, and we are iterating from the last index. Okay, we are iterating from here now. So now we are calculating the right products. So whenever the pointer is at 2, that is the rightmost pointer. So now nothing is there at the right of it. So the value will be 1 over here. So whenever the pointer is going to the next element, that is 3. Okay, now the pointer is at 3. So the right product will be 2 into 1, which is 2. Okay, and whenever again it is going to the next pointer from the right. So it will be at 4. So whenever a pointer will be at 4, the right index multiplications will be 3 into 2 into 1, that is 6. Okay, and when it is going to the next index, that is 9, the right, all the index values multiplication value will be 4 3 are 12, 12 2 are 24. So it will be coming as 24 over here. Okay, and whenever it is going to the next index, that is at first index, we have to calculate, we have to multiply 9 to the resultant element. Okay, so 4 into 3 into 2 is already calculated. So we have to make use of that value and we are multiplying with the 9, okay, which is the next element. So 24 multiplied by 9. So 24 multiplied by 9, whatever value will be coming, that will be the value for this first index. So now we have calculated the left multiplied values and right multiplied values. Okay, so product we have calculated. So this is a separate arrays for left array. This is for right array. We have created two arrays. Now we will be creating one final array. Okay, we'll be creating one final array where it will store the multiplied value of left and right. So we are calculating product, right? So for each and every index value, we know the left product, we know the right product. So now what will be the next step? We have to multiply them to get the all product. Okay, like left product multiplied by right elements product. So here at first index, if I consider, the left value is considered as 1, the right value is considered as 1. Okay, so we have to multiply it. Okay, so if you try to observe over here, whenever the index value is at first place, so it will multiply the elements from the back basically. Okay, because the right elements are considered from first, so we will be multiplying this like this. We are multiplying. So 1 multiplied by 24 multiplied by 9. So that will be coming as first. Okay. Then when the index value comes to the next element, that is 9, then we have to multiply 1 with the rest element. Okay. So here what is happening? So here 1 is multiplied by all the elements. Yeah. So left value will be how much this value? For the first index, there is nothing there in the left side, right? So we have to multiply all the elements from the right side. So we have to multiply 1 with the last index value, which is 24 multiplied by 9, because we are going from back, right? If you remember. So we are multiplying 24 into 9, whatever value will be coming with 1. Okay. So now whenever the index is coming to next element, we are multiplying 1 with the rest element, that is 4 into 3 into 2, which is 24. So what we are doing, the next value is coming as 1 again. So 1 will be multiplied with this 24, which is coming as 24. So now when the pointer is coming to this 4, then what we are doing, we are multiplying 1 into 9. The value is coming as 9 over here. 9 will be multiplied with 6. So we are multiplying these two elements, 9 and 6. Okay. And when it is coming at 3, then we are multiplying 9 into 4, which is 36. We are multiplying with 2. Okay. So we are multiplying these two elements. 36 multiplied by 2 is 72. Okay. And when it is coming at last index 2, we are multiplying 9 into 4 into 3. Whatever 108 value is coming, we are multiplying it with 1. So like that, the each and every elements is being calculated. So you saw, right? The time complexity has been reduced from O of n square to O of n, and how it is working like magic. So this is the prefix product approach basically, which we have told you in this video. So let me show you through code like how it is working so that we will get a much better idea of it. Okay, let me stop my share. I hope you can see my screen now. So here you can see like I have considered one example 21536. Okay, so what I'm doing, I've created one left array, I've created one right array, I'm creating final array, okay, which will contain the product of left and right arrays. So left of 0 I've considered as 1. The first index value for left array is considered as 1, okay, because the left to that element is nothing. So 0th element is considered as 1. So now I'm running a loop from first index, not 0th index. From first index to last index, I'm running a loop. And then I'm calculating the left array product. So left first I equal to 1, so 1 minus 1 will be 0. So here the value will be multiplied with 1. Whatever value is there at I minus 1 at index will be multiplied with 1. And then the left at 1 will be calculated. So like that, the left product arrays will be calculated for each and every index. Similar to that, for right array, what I told, it will go from the rightmost index. So rightmost index will be considered as one element, one value. And then we are multiplying with all the elements starting from len minus 2 to the 0th index. And we are calculating the right array product. And then at last, we are running another for loop, which will multiply the left elements and the right elements, like left element index values multiplied by right element index value for that specified k. So with that, we are calculating the final array, and then we are printing it. Okay, so like this, it's O of n plus O of n plus O of n plus O of n for printing. Okay, so it's O of 4n, which is actually O of n only. So it has reduced the time complexity from O of n square to O of n, right? So this is the magic of product array approach. So that's why we have to know certain data structure in array, which can help you optimize your code. So if I run this, it will show you what is the current product for each and every index values. So here, if you see the final array is coming as 90. So if you see here at first index, what will be the value? It should be 6 into 3 into 5 into 1. That is 90. So 90 is coming over here. So now when I'm going to second index value, so what will be the value for this? 6 into 3 into 5 into 2. That is 180. 180 is coming over here. Then when I'm going to second index, the value should be 6 into 3 into 1 into 2. That is 36. Then here it will be 6 into 5 into 1 into 2. That is 60. And then at last index, it will be 5 into 3 into 1 into 2. That is 30. So this is the very important problem. It's present in lead code. So try to attempt it by your own self. Then you will get the idea of it, like how product array approach is working. So in the next video, I will be explaining you about product sum approach. So there are two concepts over here, product array approach and product sum approach. So within array, if you are observing, there are a lot of type of data structures available over here within array. So one is sliding window, one is cadence algorithm, one is prefix sum approach, one is prefix product approach, then two pointer approach. So all these algorithms should be very much clear to us before actually going for interview, because interviewer can ask in any algorithms. So you should practice at least 4 to 5 variants of these type of questions so that you can very easily answer in the interviews. And the mind will come like, yes, this type of problems are coming. Now I have to apply this algorithm. So that practice should be there with you. So this is the first step that I am taking for you so that you will get the idea like how to implement these things. Then we'll be seeing you in the next video with product sum approach. Till then, it's Devjit Roy signing off. Bye-bye.